Hello guys, welcome to i-tutor Academy. In today's session, we will start with the Unit 7, subsection 3, that is some important continuous probability distributions. The knowledge of the probability density function, that is PDF, of a continuous random variable is helpful in many ways. The probability distribution PDF function allows us to calculate the probability that a variable will lie within a certain range. The usefulness of such a calculation are illustrated with the help of following two situations. So here is a situation, because these probability questions only we can do with the examples and situations only. So here is one situation 1 in IGNOU study materials MBA mmpc005 unit 7. You just refer, and the situation 2 also here, so you just read these two situations. And there is exponential distribution is here, and the time between breakdown of machine, duration of telephone calls, life of a electric bulb are example of situation where the exponential distribution has been found useful. Okay. And in the previous unit, while discussing the discrete probability distribution, we have examined the Poisson process and the resulting Poisson distribution. In the Poisson process, we were interested in the random variable of number of occurrences of an event within a specific time or space. And if any situation is found to satisfy the condition of a Poisson process, and if the average occurrence of the event of interest is m per unit time, then the number of occurrence in a given length of time t has a Poisson distribution with the parameter mt, and the time between any two consecutive occurrences will be exponential with the parameter m. And here is the solution also, and you just go through your IGNOU study material, and examples are here. Based on the example, there is a solution part also here. Okay. And activity D, activity E also based on the probability section, so you just go through it. And normal distribution, the normal distribution is the most versatile of all the continuous probability distribution. It is found to be useful in statistical inference, in characterizing uncertainties in many real life processes, and in approximating other probability distributions. Quite often, we face the problem of making inferences about processes based on limited data. The limited data is basically a sample from the full body of data on the process. Irrespective of how the full body of data is distributed, it has been found that the normal distribution can be used to characterize the sampling distribution. This helps considerably in statistical inferences. Heights, height, weight, and dimension of a product are some of the continuous random variables which are found to be normally distributed. This knowledge helps us in calculating the probability of different events in varied situation, which in turn is useful and for decision making. And finally, the normal distribution can be used to approximate certain probability distribution. This helps considerably in simplifying the probability calculation. And the properties of the normal distribution is here, and these are the properties of the normal distribution. And probability calculation also here. Suppose it has been found that the duration of a particular project is normally distributed with a mean of 12 days and a standard deviation of 3. And this is that. And symmetry, here is one chart also based on that, and equations are here. Normal as an approximate of binomial for large n and with p value around 0.5, the normal is a good approximation for the binomial. And for fractile of a normal distribution, the concept of fractile as applied to normal distribution is often found to be useful. This is here. And activity F is based on this section, and activity G also based on this section. So you just try to do this activities. And next is 7.4, application of continuous distribution. The following two examples illustrate the use of the exponential and the normal distribution in decision making. Example also here, example 7, and the solution also based on the example is here. And you just go through your IGNOU study material. It will help you for your more understanding and the term and examination. And example 8 is here, and based on the example solution also in this mmpc005 study material. And this is try to do this with the solution. And summary of this unit is here. The function that specifies the probability distribution of a continuous random variable is called the probability density function, that is PDF. The cumulative density function CDF is found by integrating the PDF from the lowest value in the range up to an arbitrary level x. As a continuous random variable can take innumerable values in a specified interval on a real line, the probability are expressed for interval rather than for individual values. In this unit, we have examined the basic concepts and assumptions involved in the treatment of continuous probability distributions. Two such a important distribution versus the exponential and the normal have been presented. Exponential distribution is found to be useful for characterizing uncertainty in machine life, length of telephone calls, etc., while dimension of machined parts, heights, weights, etc., found to be normally distributed. We have examined the properties of this PDF and have seen how probability calculation can be done for this distribution. In the final section, two examples are presented to illustrate the use of this distribution in decision making. So this is the summary of this unit 7, and in between any doubts you can contact us. The further reading materials also here, and there is no section unit based questions are in the end of the chapter, so you just try to do the activity in between. Also there is an examples are there, so try to do that. So for more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you for your support.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.